In this video we're going to be talking about roots, which are intimately linked to exponents and powers, as you'll see. So if we've got the nth root of a number a, so that number is equal to x, which means the same as saying that a to the power 1 over n is equal to x. So that's the same as saying that x to the power n is equal to a. So here we've got a number x and we multiply it by this given number of times and that gives us a. So let me show you an example. That's probably the easiest. So let's talk first about the square root. So if we've got, so we just write the square root like this. This is the most common one. So that's the same. We can also write that as, write a little 2 in there to make it really clear what we mean, or we could write it as a to the power 1/2. So we have to multiply this number x by itself 2 times. So x times x is equal to a. So we need to find this number x. So for example, if we've got square root of 4, that means that we need to find this number x that we multiply by itself to give 4, and that number happens to be 2. 2 times 2 is 4, and therefore square root of 4 equals 2. So moving on here, how about the cube root? So that is, we write a little 3, and we can also write it as a to the power 1/3. So then we have to multiply this number that we're trying to find, x, by itself 3 times. That's defined by this 3 here, and it's 3, so x times x times x gives us our number a that we know. So for example, cube root of 8 is the same as saying x cubed is equal to 8, and we know that 2 times 2 times 2 is 8, 2 cubed, or 2 times 2 times 2 is 8, so therefore the cube root of 8 is 2. And so on. So for example, if we've got the 4th root of 16, which can also be written as 16 with an exponent 1/4, that's equal to 2, because 2 to the power 4 is equal to 16. Now I've done all these nice round numbers so you can do them without a calculator, but obviously it doesn't have to be an integer. 5 to the power, the 5th root of 32, so we'd write that as 32 1/5. That's also equal to 2, because 2 to the power 5 is 32, and so on. So now let's look at some general rules for manipulating roots. So the first one I want to talk about is this. So if we've got a root of a times b, that's this, we can split that up, so then we got the root of a times the root of b. And this will be useful for simplifying. So for example, we've got the square root of 36, and that is equal to 6, because 6 times 6 is 36. And we need the square root, so something that multiplies by itself twice, 6 squared. But also, we could split it up, so we could say the root of 9 times 4. 9 times 4 is equal to 36. So that's equal to, and then so here we've got an expression that looks like that, and then we can split that into square root of 9 times square root of 4, and work these out. So 3 times 3 is 9, so the square root of 9 is 3. 2 times 2 is 4, so the square root of 4 is 2. So that gives us 6 as well. We come to the same answer. Here's another rule. So if we have a fraction, or something we can make to look like a fraction, so we've got n a over b, the nth root of a over b, then we can split that up and have the nth root of a over the nth root of b. So for example, if we've got, let's say, the square root of n over 16, that's equal to 3/4, because 3/4 squared is equal to 9/16. But similarly to what I just did over there, we can split it up so we've got the square root of 9 over the square root of 16, which is 3/4, because 3 times 3 is 9 and 4 times 4 is 16. So we get the same answer by these two methods.